Start.
Hello guys, this is Raidon Academia, and today we are still on our series on the law of indices. Okay, previously we have dropped a video on the multiplication law. Today we are going to be looking at our second law, which is the division law. Okay. So our division law simply holds that when dividing numbers with the same base, okay, dividing numbers with the same base, you will simply subtract the power of the denominator from that of the numerator. Okay, what we simply mean is this: when dividing, let's assume we have a raised to power n divided by a raised to power m. All right, so our a raised to power m will end up being our denominator, right, and this will be our numerator. So we subtract the power of the denominator from our numerator. So this is what our indices or our second law, division law, holds. Okay, that when dividing numbers with the same base, we subtract the power of the denominator from the numerator. Alright, now I'm going to give a very brief example. Okay, we have that 2 raised to power 3m minus y divided by 2 raised to power m plus y. Alright, so this is very simple. Like you can see, our bases are the same. Okay, our bases are the same. We simply subtract their powers. Okay, now we have in our first basis, we are maintaining one base, right? So we have 3m minus y, which is the power of the first. We're subtracting the power of the second, m plus y. Okay, we have to bring in our bracket for expansion. So by expanding that, we'll be having 3 raised to power m minus y. Our minus will give us minus m, and that will give us minus y. Alright, so by collecting like terms, we'll be having 2 raised to power 3m minus m will be giving us 2m, and minus y will be giving us minus 2y. Alright, if you wish, you can simplify this to be equal to 2 raised to power. We'll bring out our 2, which is common, okay, and then we'll be having m minus y. Are we there? Since we're not giving the value for m and y, this is where we're going to be stopping in our solution. We cannot go further since we don't know the value or the numeric value of our given variables. Alright, so we're going to take a second example quickly. We have that 5 raised to power 3y divided by 5 raised to power x is equal to 125. Alright, and then we also have that 3 raised to power 2x divided by 3 raised to power 3y is equal to 1. Okay, and we are asked to find the value of x and y respectively. Now in solving this, we'll be using our indices law still, but this will be leading us back to simultaneous equation. Okay, so I'll be calling this our equation 1 and our equation 2. Alright, now so we're going to work with our equation 1 quickly. We have that 5 raised to power 3y. Now this division sign, like I said, since the bases are the same, we'll simply subtract the power of the denominator from the numerator. Okay, so be giving us now 125. You can also simplify that, okay, to a simpler form. We'll be having 5 raised to power 3. Alright, that's 5 times 5 times 5 will give us 125. Now since the bases are the same, we can equate the power. So we'll be having that 3y minus x is equal to 3. Okay, we can still make our x subject of the formula. Alright, let's continue. If our x go the other way, since it is negative, it will go to our right hand side, and we'll bring in our numbers to the left. So if our minus cross over the equal to, it will become plus. We'll be having 3y. This is a positive. Since if you come over the equal to, it will become negative. Alright, so we'll be having minus 3 to be equal to positive x. Alright, now our x is equal to this. We can call this equation A. Right, now we are through with our equation 1. We're moving to equation 2 quickly. We have that 3 raised to power 2x. Now the bases are same, so we'll simply subtract the powers. Okay, minus 3y, right, is equal to 1. Now anything raised to power 0, alright, anything raised to power 0 is going to give us 1. So in place of 1, we'll be using 3 raised to power 0, alright. It's a 0 power law that whatever is raised to power 0 must be equal to 1. So you can equate 1 to any variable raised to power 0, alright. Now, since the bases are the same, we can simply equate their powers. So we'll be having that 2x minus 3y is equal to 0, alright. And then we can work on that. We'll be having 2x to be equal to, now we'll be taking our y to the other side. We'll be having 3y. I'll be there now. But before then, we already had that our x is equal to 3y minus 3. So I'll be substituting for x 3y minus 3 to be equal to 3y. Alright. Quickly. Okay. We are going to continue from there. We are going to be expanding our bracket. 2 times 3y will be giving us 6y. 2 times minus 3 will give us minus 6. Alright. And then it's equal to 3y. Alright. Now we can solve for y. We'll collect like terms. We'll bring our y to this side. Since it is positive, if it comes over the equal to, it becomes negative. Okay, so we'll be having minus 3y. And when our positive 6 goes over the equal sign, it becomes, our negative 6 goes over the equal sign, it becomes positive 6. Alright, so we're going to work this out. 6y minus 3y, we're giving us 3y is equal to 6. Alright, to get the value of y, we simply divide both sides by the coefficient of y, which is 3. So our y is equal to 2. And we can substitute this in equation A, alright, to find the value of x. So we have that 3y is 2, alright, minus 3 is equal to x. So 3 times 2 will be giving us 6 minus 3, alright, to be equal to x. 6 minus 3 will be giving us 3, therefore our x is equal to 3. So this is how we can use our division law. By applying it, we can solve given problems, okay? We have come to the end of our series on the division law of indices. If you've not subscribed to our channel, please do so. If you've not seen other videos, you can look up our page and look at all our videos. I'm sure they will be helpful. Don't forget to share this video with others. See you in our next class. Thank you.